Hi everyone, and welcome to this first class in this section of aerodynamics. In this case we will be studying forces which are acting on an airplane. Okay, so here you have basically the schematic forces, the most basic forces, okay, that you may encounter in an aircraft. You have, of course, a lift, okay, which the lift is provided by the wings, as you can imagine, and allows the aircraft to actually go up in the sky, right? You have the weight, which is related to the whole spacecraft. You have the thrust, which is based on the operation of the engines. And you have the drag, which is kind of a condition, you have just some drag because you're going to a certain speed. Okay, so because of viscosity and because of the conditions of the flow around the wings and around the spacecraft itself, you just have some drag. Okay. So let's see a bit of a description of these forces and how they relate to the conditions of flight of the aircraft. Okay, so the lift depends mainly on the velocity of the aircraft and also the wing surface. Okay, so for those of you who know a bit more on this case, you will know that it also depends on some other factors, but I just want to point out different elements that are key, okay, to understanding each one of the forces. So as I said, lift depends on velocity, actually a velocity squared, okay, and the wing surface. The drag also, the same way as the lift, depends on the velocity and the wing surface. Okay, so these two depend basically on the velocity and the fact that we have wings, okay, so just some kind of wing surface, right? Also the drag, there's of course a drag which is related to the whole geometry of the spacecraft itself, okay? And this does not, well, this depends on the velocity also. Right, what else? The weight, okay, which I mentioned as W, is fixed. The idea is that the weight is just a variable that you will have in any condition, okay? Of course, this can vary over time due to the fuel consumption, and the weight may vary a bit, okay, considering that the fuel is expelled from the aircraft, but in general it can be assumed as fixed, okay? And thrust, T, which is this over here, will depend on the pilot's intentions, okay? So, of course, it depends on other conditions. It is quite, thrust is usually quite exhaustive to analyze correctly, but the idea is that the pilot has control of the thrust, as you can imagine. Okay, so one important thing to take into account is that for the aircraft, we need an equilibrium, okay? So, as you may know, Newton's second law states that if you have a difference in forces, say that lift, okay, this over here, is actually bigger than weight, you can imagine that the aircraft will actually go upwards, okay? So, the idea here is that if you want an equilibrium, alright, so say static flight, normal flight at a certain height, you need all of these forces to be equal each one, okay? It's important. So the idea is lift must be equal to weight so that we don't have an extra force over here, and thrust has to be equal to drag. And this is a condition which is completely normal to consider when doing any kind of operation with aircraft, okay? So as I mentioned, Newton's second law states that a difference in force, okay, will imply an acceleration to a certain mass. So as I said, if the weight is bigger than the lift, okay, then you would have a difference in forces, and therefore it would result in some kind of force, which is the weight minus the lift, okay, which would be different to zero, and because it is different to zero, the aircraft would be pulled downwards, okay? Of course, for instance, when you're taking off, the lift has to be bigger than the weight, right? Because otherwise you just cannot take off. The aircraft would just stabilize in the platform, and that's not what we want. So the idea is just this, okay? So depending on the operation that you need to kind of adjust the variables one to each other, okay? Right, so one other interesting thing to note is that, as I mentioned before, lift depends on the velocity. Okay, drag also depends on the velocity. So in takeoff, you basically have zero lift because the aircraft is still, okay? And when you increase thrust, all right, you have a very high force over here and absolutely no drag because the velocity is zero. So initially, you understand that the aircraft is just pushed, okay? Has an increase in velocity because there's a thrust which is a lot bigger than the drag. Of course, the drag starts to grow in a way, okay, because we are having higher velocity. But in the idea is that the thrust is very bigger or very, increased with respect to the drag, of course. And in addition, when the thrust operates, you start to have a velocity of the aircraft, and therefore the lift starts to grow, okay? And as you can imagine, it is when we have a certain velocity that the lift is actually equal to the weight. And in that case, what happens is the aircraft is in momentary equilibrium, okay? But as you can imagine, if we increase a bit more the thrust, and if we can continue to increase the velocity, then the lift is bigger than the weight, and therefore the aircraft starts to go upwards. Okay, so this is what happens. Of course, the thrust is usually bigger than the drag for these conditions, but in general conditions or when we're in flight, okay, the thrust will be considered to be equal to drag.